now let's move forward to solving problems involving rational functions. So let's have this example 1. Problem: consider a 300-meter track for foot racers. The speed, or denoted as S, of a runner can be computed by taking the time, or denoted as T, it takes him to run the said track, and applying it to the formula S equals to D over T. Write a rational function defining the relationship of the speed and time. So we have speed as S and time as T. So what is our given in this problem? So we have a given 300 meters. So this 300 meters track. So that is our distance, the fixed distance. So now, how can we relate your speed to time? So here is the formula. So we have S equals to D over T. So your S is equals to 300. So the distance is 300 over time. So since we can get the speed using the time it takes him to run the said track, or the 300-meter track, so that means that S is dependent or a function of time, or T, or your speed is related as function of time. So we have 300 over time. Your time here, or your T, is the independent variable, meaning it is the input independent variable. And our S of T, or the speed, is our dependent variable. So it depends to your time. So this is now our function, the rational function for the relationship of speed and time, given the 300-meter track. So now let us have the second example in solving problems involving rational functions. So we have to relate the situation in example 1 earlier. So assume that a runner runs the 300-meter racetrack at different run times as given below. So we have here the table of values for the time, or T, in seconds. So we have 24, 30, 36, 42, 48, and 54. So we have 6 times, or 6 times the runner runs the 300-meter racetrack. So we are going to find the speed in this 6 times. Okay? So first, let's solve for time, which is equals to 24 seconds. So from this previous example, we have S of T, or the function of time, speed of the speed function of time, we have 300-meter distance over your time. So let's just substitute 24 seconds in your time. So we have S of T equals to 300 divided by 24. We have 12.5. So this is meter divided by seconds. We have meter per seconds. So this is the speed if the time of the runner is 24 seconds. So what about if it's 30 seconds? So let's have T equals to 30. So let's substitute. So we have 300 over 30. We have equivalent to 10 meters per second. So it is lesser lesser than it's less than the first one because the runtime is the speed is just 10 rather than 12.5 because the time is much slower or higher time. So we have here 10. So for t equals 36, we have s of t 300 divided by 36, we have 8.33 meters per second. So we have here 8.33. Next so this is for t is equals to 42. So we have s of t, which is equals to 300 divided by 42 seconds. We have 7.14 meters per second. And let's just write it in the table, 7.14. So for t is equals to 48, we have s of t equals to 300 over 48. We have 6.25 meters per second. And for the last time, which is 54 seconds, so we have a speed equivalent to 300 divided by 254. 300 meters divided by 254 seconds, we have equals to 5.56 meters per second. So as you can see in this table, we have this time, specific time in seconds related to its speed, which is computed using the formula of our function s of t equals to 300 over time. So as the time increases, your speed decreases, meaning the runner runs the field, the racetrack slower. So let us have this last example in solving problems involving rational functions. So example 3, we have in an inter-club badminton league, the group representing Tala has won 14 out of 25 games with a winning percentage of 56%. We have previously solved that for them to have win percentage of 80%, they need to win 30 games in a row. What will be their winning percentage if they win A 40, B 50, C 60, and D 100 games in a row? So we're gonna solve the winning percentage for this number of games that they have win in a row. Can they reach 100% winning percentage, and what? So these are the problems. The first, we need the given. So our given, we have a 56% winning percentage because we have 14 out of 25 games. 14 wins out of 25 games. So 14 divided by 25, we have 0.56. That is why we have 56% winning percentage. So it says here that we have previously solved that for them to have winning percentage of 80%, meaning this one is 0.8, they need to win another 30 games in a row. So we have 0.8 here as your winning percentage. So how did they get that? That is 14 plus 30 all over 25 plus 30. So that is 44 over 55, which is equals to 0.8 or 80%. So now, we need to know the winning percentage if they win 40, 50, 60, and 100 games in a row. So let's make a table here for us to fill. So we have the number of, let B the X be the number of games in a row, and the P as your winning percentage. So we have 40, 50, 60, and 100. So how can we compute the winning percentage? So by this, we have the winning percentage, which is equals to 14 plus X. So the number of winning the number of games in a row over 25 plus the number of games in a row. So we are assuming here that the next 40, 50, and 60, and also 100 games in a row, they're gonna win. So let's now solve for the winning percentage. So if your X is equals to 40, we have winning percentage 14 plus 40 over 25 plus 40. So this is equals to 0.8308. That means in percentage, you just multiply it to 100%. We have 83.08%. So let's fill this up, 83.08. If the X is 50, what is our winning percentage? So 14 plus 50 over 25 plus 50, we have 0.8533. So just times 100% to get the percentage, we have 85.33%. And for X is equals to 60, let's just erase the solution. For X equals to 60, we have P equals to 14 plus 60 all over 25 plus 60. So we have here 74 over 85, which is equivalent to 0.8706 times 100%, that is equals to 87.06. Next, for X equals to 100 games in a row, we have P equals to 14 plus 100 over 25 plus 100 equals to 114 over 125, which is 0.912 times 100%, we have 91.20%. So here is the data for the winning percentage. If they've won 40 games in a row, that is 83.08. If they've won 50 games in a row, they have a winning percentage of 85.33%. If they win in 60 games in a row, another 60 games in a row, they have a winning percentage 87.06%. And for 100, we have 91.2 or 20%. So the next question, can they reach 100% winning percentage, and why? So the answer is no. Why? Because in this statement, 14 out of 25 games, they have already lost 11 games. So if they've won the whole succeeding games for the next coming days perfectly, if they won perfectly, they still lost the 11 games. That is why they will not reach the 100% winning stage. They can just approach the approximately 99% but does not become 100% winning percentage. That's it for the solving problems in rational functions.